Hello and welcome to Cannon County High School, Algebra 2. Yesterday we talked a little bit about inverse sine, cosine, and tangent, and we figured out how to find angles based on that. And now that you understand that, you can now kind of put together the last 3 or 4 days of what we've learned to find the angles and the sides of any right triangle. Not just those special 30, 60, 90 or 45, 45, 90 triangles, but we can now do this with any right triangle. And so that's what we're going to do today. So Mr. Lyon, I'm afraid we still have some quarantine going on, so you're going to have to sit over here. Keep an eye on us. And let's try this. Let's see here. There we go. We are finding angles and sides of right triangles. So let's see here. We have a triangle and we know it's a right triangle. We know the hypotenuse is 7 and we know that the angle is 27. And I want you to find this missing angle, or this missing side rather, and I want you to round to the nearest hundredth. Well, how can you do that? Now we're going to kind of put together several things that you understand and know how to do. And you're going to see it's really relatively easy to do this with your calculator just by solving a very simple equation. Remember we talked about SOHCAHTOA. And basically that is just a way for you to remember that sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. These are equations that we're going to set up based on the information given, and we're going to solve for whatever side or angle is missing. So look at what's given here. We're given this 27-degree angle, and we're given this side. What would you call this side? Would this be the adjacent side, the opposite side, or the hypotenuse for this 27-degree angle? Well, yeah, it's the opposite side. So you know you have the opposite side, and you're given the hypotenuse. The hypotenuse is always across from the right angle. So opposite and hypotenuse, which of these, sine, cosine, or tangent, can you use for opposite and hypotenuse? Opposite and hypotenuse, you're going to use the sine function. So let's do that. Let's write an equation to solve for x. We know that the sine of the angle, in this case 27 degrees, is going to equal the opposite side divided by the hypotenuse, x divided by 7. And that's the equation that we're going to solve. And it's relatively simple to get x by itself here because all you have to do is multiply 7 to both sides. You're going to multiply both sides by 7, and what happens when you do that? Well, that means that x is going to equal 7 times the sine of 27 degrees. All I have to do now is figure that out on my calculator, and we are done. So take out your calculator, and we want to check first and make sure we're in the correct mode because we want to be in degrees for this problem and not radians. So look at your mode. Looks like for me I'm in degrees, which is what I want. There might be some problems where we have to switch to radians. But go back now, and we're just going to type in 7 times the sine of 27. So 7 times the sine of 27. And we're going to round this off to the nearest hundredth. So what does it say? It says 3.177, so that would be 3.18. So that means x equals 3.18. 3.18. And just look at, these triangles aren't drawn to scale perfectly, but just look, does it look like that could be 3.18 if this side is 7? Yeah. I mean, again, these are not drawn to scale, but you get the idea. And it's really that simple. Pick out which equation you're going to use and then solve for it. Let's try another one. Okay, this time you've got a 41-degree angle. And you tell me, what do we have here? 12 and x. What would you call the 12 and what would you call the x as far as opposite, adjacent, and hypotenuse? Well, the opposite side would be this side for the 41-degree angle, and we don't really have any information on that. The 12 is adjacent, and the x is hypotenuse. So let's go back up here to SOHCAHTOA. Which one talks about adjacent and hypotenuse? cosine. Cosine is equal to adjacent over hypotenuse. So for this one, you could write the equation cosine of 41 degrees is equal to the adjacent side divided by the hypotenuse. Well, now we just have to solve for x again. Solving for x is maybe going to be a little more challenging than last time, but not too bad. If you think of this, we have the x in the denominator here. That's the part we don't really like. If we were to change this into a proportion just by making that cosine of 41 divided by 1, well then you know that you could just cross multiply 12 times 1 is equal to 12, and x times the cosine of 41 equals x times the cosine of 41. And now you could divide both sides by the cosine of 41, and you would get x equals 12 divided by the cosine of 41. That's what we're going to type into our calculator to find x. So x is going to equal whatever 12 divided by the cosine of 41 is. So here we go. 12 divided by the cosine of 41. And we're going to round this off to the nearest hundredth again. Let's see, that is 15.90 if we're going to round to the hundredth. 15.90. 15.90. And it makes sense that this hypotenuse would be longer. We would think that something was wrong if we got a number less than 12, right? But it makes sense if it's 15.9. That looks about right. Again, not drawn to scale, but you get the idea. Okay, let's try another. All right, this time we're trying to find an angle. We haven't done this yet. But from what you learned yesterday, you can do this relatively simply. Again, what have we been given here? Well, remember, for SOHCAHTOA, take a look at what we have for this angle. The angle is, we have the opposite side and the adjacent side. This is the hypotenuse, so we have opposite and adjacent. Which one talks about opposite and adjacent? Tangent. So you're going to say the tangent of some angle theta that we don't know is equal to the opposite side divided by the adjacent side. How do you find the angle if you know the tangent? Well, if you remember from yesterday, you know that you're going to use inverse tangent to do that. So on your calculator, you're going to take the inverse tangent of 5/7. So on your calculator, you know that theta is going to equal the inverse tangent, that's what we did yesterday, of 5/7. So that's what we're going to type in. And since let's find the answer in degrees. Let's just leave the calculator in degrees mode. So we're going to hit the second, again, just like yesterday, we're going to hit the second function button and then the tangent button. So we're going to hit second tangent for inverse tangent of 5/7. And let's round off in degrees here. Let's round off to the nearest tenth of a degree. Looks like we've got 35.5 degrees. So that means that theta has to be 35.5 degrees. Now, the interesting thing about what we're doing is that once you know that theta is 35.5 degrees, I'm not asking you to do this, but could you now figure out this angle and this side? Could you solve the entire triangle if you wanted to? Well, of course, you know that all the angles add up to 180, so you could take 180 minus 90 minus 35.5 to get this. And to find this side, well, you have a lot of choices. You could use the Pythagorean theorem with those two, or you could use another trigonometric function, whatever you want to do. But once you've kind of unlocked one of the sides or one of the angles, well, then you've really unlocked the entire triangle. Okay? So this is what I'd like us to do. Instead of doing an IXL, I would like you to draw this triangle on a piece of paper, pause the video, and try to find theta to the nearest tenth of a degree. Do that right now. Pause the video, and then when you unpause the video, I will do the problem and we'll see if we got the same thing. So go ahead and pause the video, and I will see you in just a second. Okay, we're back. How'd you do? Which of the ratios did you use? Did you use Did you use sine, cosine, or tangent? Well, for this one, let's see what we have here. We have the opposite and we have the hypotenuse. Opposite and hypotenuse, that's sine. Sine equals opposite over hypotenuse. So the equation we're going to solve for this one is the sine of theta equals the opposite side divided by the hypotenuse. So that means theta is going to equal the inverse sine of 21 over 28. Again, once you figure this out, it's really not that difficult. At least the equations are quick to solve anyway. Inverse sine of 21 over 28, like that. Hit enter, and it says 48.6 if we were going to round off to the nearest tenth. 48.6 degrees, and that's the answer, 48.6. That's it. Now, just like we talked about before, if you know that this is 48.6, could you figure out this angle and this side? Of course you could. It would be really quick and easy to do that. So let's do another one like that. Let's have you pause the video, draw this triangle on a piece of paper, pause the video, and we'll come back and see if we get the same answer. And we're back. Let's see, what should we do for this one? Here's the angle. We have the opposite and the adjacent. Opposite and adjacent has to do with tangent. So the equation this time is the tangent of the 42-degree angle equals the opposite side divided by the adjacent side. Well, how are we going to solve for x? In order to get x by itself, we need to multiply both sides by 104. So x is going to equal 104 times the tangent of 42. All right, let's get out the calculator. 104 times the tangent of 42. What do we get? We get 93.64. 93.64. So x equals 93.64. And then just take a look at the triangle. Does it look like it could be 90? Well, this was 104, so 93, yeah, that looks about right. Again, this isn't drawn to scale, but it's pretty close. All right, let's do another pause the video problem. Pause the video, draw this on a piece of paper, and see if you can solve it. All right, we're back. Which trigonometric ratio should we use? Let's see, here's the angle. We've got the adjacent side and we've got the hypotenuse. Adjacent and hypotenuse, that's cosine. So the equation we're going to write is the cosine of theta equals the adjacent side divided by the hypotenuse, 11 divided by 15. Finding angles is relatively simple now because you know you're just going to take the inverse cosine. So theta is just going to equal the inverse cosine of 11 over 15, whatever that is on the calculator. So let's see, what is that on the calculator? Inverse cosine of 11 over 15. Second cosine 11 over 15. And we get 42.8 degrees. 42.8 degrees. I talk a lot about the ACT test in this class, and again, these are problems that the ACT test really likes because once you understand how to do them, they're very quick and easy to solve. The ACT is all about testing as wide a variety of mathematical concepts as they can. And the best way for them to do that is to make problems that not only test concepts, but that you can solve quickly so that you can do lots and lots of problems. And this is another good example of that. They can give you a triangle, ask for an angle, or ask for a side, and as long as you understand the trigonometric ratios, you should be able to do it really quickly. All right, last one. Let's do our last pause video here. Pause the video and solve for x. Okay, we are back. What should we use here? Here's the angle. We've got opposite and we've got hypotenuse. Opposite and hypotenuse, that's sine. So the sine of 4 degrees is equal to the opposite side divided by the hypotenuse. Solve for x. The only thing keeping x from being by itself is this 74. So we're going to multiply 74 on both sides. So that would be 74 times the sine of 4 degrees is equal to x. 74 times the sine of 4 degrees. And what do we get here? 5.16. X equals 5.16. Okay? Now this is not drawn to scale because that's actually much bigger than a 4-degree angle. It would be a lot skinnier than that. But you know that this side should be significantly shorter than the 74, and it is, 5.16. So that's it. No IXL this time. We just did those pause problems, and that way we can solve any angle and any side. As long as we know at least one angle and one side of a right triangle, we can solve for the whole thing now. Okay? All right. Thank you for watching, and I will talk to you tomorrow. Bye.